Hello and hi everyone. So today we would like to present our group assignment for classical mechanic by section 3. So next, these are our team members. From left, we have NURKHAIRINA. Next, we have FATIN AINA. In the middle, we have AISHA DALILA. Next, we have FATIN DALILA. And lastly, we have NADA ATIYAH. Here are our contents for today. We have prepared 5 solutions for 5 questions that we have picked before and discussed together. This is the question 1 looks like. This is the answer for the parallel connection. When two springs of stiffness K1 and K2 are connected in parallel, as shown in the figure, the force applied to the mass is distributed across both springs. Each spring experiences the same displacement, so the total restoring force is as below. F equal to K1x plus K2x. From Hooke's law, the effective spring constant for parallel spring is K equivalent equal to K1 plus K2. The equation of motion for the system is ma double dot plus K equivalent x equal to 0. That will give us the angular frequency of oscillation is omega equals to square root K equivalent over m. Or we can simplify as omega equal to square root K1 plus K2 over m. Next, let us move for the series connection. When the springs are connected in series as shown in the figure, they experience the same force but different displacement. The total displacement is the sum of the individual displacement, which is x equal to x1 plus x2, where x1 is equal to f over K1 and x2 equal to f over K2. Next, we are going to substitute these values. X equal to f over K1 plus f over K2. The effective spring constant is 1 over K equivalent equal to 1 over K1 plus 1 over K2. That will give us K equivalent equal to K1 K2 over K1 plus K2. The equation of motion is mx double dot plus K equivalent x equal to 0. And that at the end will give us the angular frequency is omega square root K1 K2 over in a bracket K1 plus K2 close bracket m. Therefore, the angular frequency equation for the parallel connection and the series connection has been shown.
A simple pendulum of length L oscillates with an amplitude of 55 degrees. For the first question, what is the period? We can use the equation of 2 pi times Z L over G, but this is only valid for small oscillation which was theta naught less than 1. Since the oscillation is t, the amplitude is 45 degrees, we need to times the theta naught with function of theta. Function of theta is given by elliptical integral as stated in the solution given. For small theta naught, we use f theta equal to 1 plus 1 over 16 theta naught squared. We substitute the 45 degree into the equation and we got t is equal to 1.016 theta naught. Moving to the next slide, this is the solution for B and C. If this pendulum is used as a laboratory experiment to determine the value of G, find the error included in the use of elementary formula T naught is equal to, and C, find the approximate amount of third harmonic content in the oscillation of the pendulum. For solution in B, we need to find G experiment first, based on the equation 4 pi squared L over T naught squared. We substitute the T naught with 1.016 T naught into the equation. G experimental we got equal to G over 1.032. For measure the error is, we need to use the equation of G theoretical minus G experiment over G theoretical, and we got 3.1% for the question in B. And C, we need to find the third harmonic content. This question depends on the first question that we answer in A. We can use 1 over 16 theta naught to the power of 3. Substitute theta is equal to 45 degrees into the equation and we get 3% for question in C. For a larger A, motion of pendulum not perfectly sinusoidal and have higher harmonic.
My name is FATIN AINA and I will explain about question 3. So the solution for question 3, initial velocity is 25 meter per second. The angle for maximum height, let Vx equal to V cos theta naught and Vy equal to V sin theta naught. The speed function is V equal to V naught cos half theta naught. Substitute speed function into Vx and Vy. Then the equation for height is H equal to Vy squared over 2G. Substitute Vy into equation H and let f theta naught equal to cos squared half theta naught sin squared theta naught. Differentiate df over d theta equal to 0. We use product rule to differentiate the function and we got theta naught equal to 53 degree. For the angle for maximum range, the equation for R is 2Vx Vy over G. We substitute Vx Vy into R. Then we got the equation R. Let f theta naught equal to cos squared half theta naught cos theta sin theta. Using product rule again to differentiate df over d theta equal to 0. Then we got the theta naught equal to 37 degree. For C, maximum height at theta naught 53. We substitute V naught equal to 25 meter per second and theta naught equal to 53 into equation H. Then we got the height equal to 7.1 meter. For the maximum range, we substitute V naught equal to 25 meter per second and theta naught equal to 37 into equation R. Then we got the range is 55.4 meter.
My name is ATIYAH binti KAMAL BAHARIN, and I will explain about the differential equation of motion for a projectile when air resistance is proportional to the square of speed. We will also need to check if these equations are separable and derive the x component of velocity as a function of distance traveled. So the equation of air resistance is given by Fr is equal to negative CV square. Negative indicate that air resistance always oppose the motion. Next, we apply Newton's second law of motion, which is m dv over dt is equal to negative cv square, unit vector of velocity, plus mg, unit vector of j. Then, we need to break this equation into x and y component. We define the velocity component as vx is equal to x dot and vy is equal to y dot. The total speed is given by v is equal to square root of vx square plus vy square. For the x component of acceleration, dvx over dt is equal to negative c over m v square vx. And for the y component, dvy over dt is equal to negative c over m v square vy minus g. Now, we need to check if these equations are separable. We express them in terms of s, the distance travelled along projectile path. Using the chain rule, dvx over dt is equal to dvx over ds dot ds over dt is equal to v dvx over ds. Rewriting the x component equation, we will get x dvx over ds is equal to negative c over m v square vx. Then, we introduce gamma is equal to c over m and solve the equation. The equation will be dvx over ds is equal to negative gamma vx. We will now separating variable and integrating. Dvx over vx is equal to negative gamma integrate ds. With that, we will substitute ln into the equation and it will be ln vx is equal to negative gamma s plus c. Then, exponentiating both sides, we will get vx is equal to e c e negative gamma s, and setting the ec is equal to vx naught, the initial velocity in the x direction, we will get vx is equal to vx naught e negative gamma s.
Moving on to question number 5, the question asks us to find the acceleration to A, the truck, and B, the road. To find the acceleration of the truck, we first need to find the net force using Newton's second law, which is F equals to ma. Based on this question, we would know that there are two types of force. First is the inertial force, and second is the friction force. For the inertial force, the equation will be F equals to ma, where A is given by g over 2. While for the friction force, it will be mu k times by mg, where the mu k is given by 1 over 3. From here, we will find the net force, which is F initial minus the F friction. Therefore, we can now include the F into the formula to find the acceleration in F equals to ma. The final answer would be A equals to g over 6, which g is being the gravitational acceleration. For question B, we will find the acceleration of the box relative to the road, which is the ground frame. In the ground frame, the only force that acts on the box is the kinetic friction. The friction force mu k times by mg is equal to 1 over 3 mg. From here, we know that it is the net force. From here, we can now apply the Newton's second law, which is F equals to ma. We can find the acceleration of the box relative to the road, and the final answer would be g over 3.